working with trig functions, and it's important to recognise the inverse of these trig functions. So let's just start with y equals sine x. And that function says, and as you remember we sort of did a little mapping idea when we first introduced functions, get an angle. So this is an angle, and this is the sine of the angle. So the sine function grabs an angle, works out the ratio, the sine ratio, and maps it to another point there. And the idea of the inverse, so this is y equals sine x. The inverse says, okay, we've got the sine, we've got the, and don't forget sine is between minus -1 and +1. So we've got a decimal here. What angle has that as a sine? So that is the inverse. Now how do we write the inverse? We say y equals sine to the -1x. That means I've got a value, I've got a decimal that is a sine ratio. This says go find me the angle. So this will give me the angle that has this particular sign. So the inverse is y equals sine to -1x. Now don't get confused, that's not 1 over sine x, that's very, very different. Another way to write sine to the -1 is arc sine. Both of those mean exactly the same thing. So that is the inverse of y equals sine x. Now one of the tests we had for an inverse function was that if we drew a horizontal line and it cut the graph in more than one spot, then it has no inverse. So y equals sine x looks like this. And you can see that there is any number of horizontal lines that I could draw where it'll cut the graph in more than one spot. So as it stands, y equals sine x does not have an inverse over the entire domain, but we've also seen that if we restrict the domain, the values of x, then we can determine inverses. Now, if we go from here to here, now that point there corresponds to pi on 2, and this is minus pi on 2 in radians, so this is the origin. So if we go, this is defined for x as between minus pi on 2 and plus pi on 2. Okay, so then we have an inverse, and we can apply the horizontal line test just over that domain, and there's nowhere you can draw a horizontal line and it will cut the graph more than once. So the inverse is only defined over that domain. The same for cos, y equals cos x. The inverse is y equals inverse cos of x. That means I've got a cos ratio, find the angle, and y equals tan x, and y equals inverse tan x. Now another word for inverse cos is arc cos, and another one for there is arc tan of x. That means I've got the tan ratio, go and find me the angle that has that. Okay.